When you press B on your controller, you can see the small menu appear near your wrist. You can move the cursor, press buttons, and in this lecture we will see how it works. Let's open our VR pawn, and here we're gonna have to find input actions that handle menu toggling. It is the same function that takes input true or false that toggles the menu on and off. As you can see from this code, in VR user interface it's not just a widget, but it's an actor that contains a widget on it. Let's take a closer look at how it works. As usual, it starts with a begin play, where, when we open the menu, we add a specific input context. Next, we set up the references. Let's take a look inside. Here we search for two widget interactions components on our pawn. And depending on the point index, we save one of them to the left or right widget interaction component references. If we will go back to our VR pawn and inspect the motion controllers, we can find a parameter here called motion source. Depending on the motion source, different data will come to the motion controller component. And as you can see, we have two more motion controller components with left aim and right aim sources correspondingly. So our widget interactions components are attached directly to those motion controllers. And the references to those interaction components we save here. In the next function, we will set references to our aim controllers. Because of their motion source, they will receive the transform pointing exactly where we point with the controller. That direction is used when we decide at what widget you are pointing when interacting with a 3D menu. So we will filter the existing motion controllers by the motion source. Next, we're gonna play a timeline that's gonna be used for appearing and disappearing. Here, as you can see, we have our widget. The user widget class that is used is specified over here. Let's open it. As you can see, it's exactly the menu you have already seen before. This means you can create the same widgets for VR as you do for any other kind of games. Let's see, for example, this button, Restart. We have an event binded here, and we just opened the same level. This causes the restart. To animate the widget appearance, we first save its relative scale. Then, using the timeline, we're gonna change the scale over time. Timeline will just technically gives us some value of this curve specified over time. In our case, it will represent the scale of the widget, that in case of appearance will go from 0 to 1, and then when we close it will go from 1 to 0, so we're gonna just plane this timeline in reverse. Here, as you can see, we get the current value from the curve multiplied by the original scale and set it as a relative scale of the widget. And in-game, it's gonna look like this. When timeline finishes and we have the scale of the widget equals to 1, we get the size of it and set some limits for the cursor. Next, for the case the timeline was playing backwards, so we were closing the menu, we will attach the widget interaction component back to the aim controller and will destroy the menu. So, what happens on event tick? This code first gets the position of the motion controller, then adjusts the location along the plane that we can create in front of us, located in this motion controller position, and sets the menu position over there. After that, we rotate our widget towards the camera. The next code toggles the logic between the cases when we are moving the cursor with the same hand or pointing to the menu with the opposite hand. Depending on that, later we're gonna get the position of the cursor differently. Let's take a look at how it happens. So for example here, same hand and same hand cursor. But right now I have the menu on the right hand while pointing to it with my left hand. And the other way around. Menu on the left hand cursor, now pointing with my right hand. So these are two different cases we are handling with that code. Let's take a look on how we do this exactly. The usage of menu laser here indicates that this is the case when we are handling the opposite hand. Over here, if we're gonna open it, we can try to see how it looks like. Here it is in the game. So we first turn it on, and then we tick the start and end of the laser. Here we can use the widget interaction component to get the trace of the laser based on the controller aim. And then we're gonna pass those values to the Niagara VFX that you have seen before. Let's search for point array. Here it is. These are 2 points, the beginning and the end, that we set from the code using our trace. Now, for the case of the same hand, first of all, we turn off the laser over here. Then we attach our widget interaction component to the cursor and set the specific relative location. The cursor is a white static mesh sphere attached to our widget. And next, we're also going to have to take its position. Here we directly use the input action values of the inputs that move the cursor to actually calculate the cursor location. The last part is very interesting, is actually how do we handle the click when we move the cursor over something and we press, what happens. So here we have our input actions, events, and as you can see here, what we do, we simulate the left mouse button click. So if you remember, we have just the ordinary buttons here, and here they will just receive the same click they would receive if that not gonna be a VR game, but just a simple game, and you're gonna be just clicking those buttons. The last thing is the logic how we finally handle the closing of the menu, which happens on the menu toggle over here. So as you can see, we received the event, we removed the input context we previously pushed for interacting with the menu, and we play this timeline in reverse, which causes the scale of the menu going from 1 to 0. At the end, we attach the widget interaction component back to its motion controller and just self-destroy. So that's all for the menu, and we will continue in the next lecture.